So, picture this. You're standing like inches away from this massive 4-screen video wall, and the image is just totally flawless.
Oh yeah, no stretch pixels, no weird color banding at all.
Right, exactly. So today we're taking a deep dive into the spec sheet for the Avenview MLT-PROWall-4K processor. Basically, we want to see exactly how its hardware pulls off this seamless, uncompressed 4K illusion.
Because, I mean, it's one thing to see the final display in a mall or lobby, right?
Yeah, totally.
But dissecting the actual mechanics, like how a single processor takes a raw 4K feed and maps it perfectly across multiple 1080p outputs, it reveals some pretty serious engineering.
It really does. So at its core, this Avenview unit is a 4-channel 10-bit processor. It takes an uncompressed 4K or 2K input and just perfectly dissects it.
Just slices it right up.
Yeah, I look at the process kind of like a highly trained traffic cop, just directing millions of pixels perfectly to their designated screens without losing a single one.
That precision is exactly why the spec sheet really heavily emphasizes the 10-bit 4.4.4 full bandwidth sampling.
Right, which is huge.
It is, because unlike 4.2.0 subsampling, which basically just throws away color data to save bandwidth.
Which usually completely ruins sharp text or logos, by the way.
Exactly, it makes them look terrible. But 4.4.4 sampling maps a unique color value to every single pixel.
So you retain all that pure, vibrant color data. I mean, that explains why the image holds up even when you walk right up to the glass.
Yeah.
You aren't getting that awful color bleed.
Right. The processor prioritizes data integrity over compression, which, is pretty much non-negotiable for commercial spaces where people are right up close to the screens.
Makes sense. But pushing that massive uncompressed 4K signal is really only half the battle, right?
Mm-hmm.
Because the real nightmare for AV installers is mapping those pixels onto weird, non-standard screen layouts.
Oh, the irregular artistic arrays.
Yeah, like screens tilted at random angles or offset from each other. The specs say this unit handles all that, but I'd assume you'd need a dedicated PC node and like an IT degree to set that up.
You definitely think so. But honestly, the surprising part is that no PC is required at all.
Wait, really? No PC?
None. It bypasses the need for an external OS completely. They baked 256 predefined layouts directly into the hardware.
That's wild. So how do you actually control it then?
You literally just toggle the front panel DIP switches, or you can use an IR remote to select your rotation angles and positions.
Oh, wow.
Yeah, it's a massive time saver for on-site deployment. It just eliminates those points of failure you usually get with software-based matrixing.
Okay, but what if you want to scale way beyond just a standard 4-screen grid?
Well, you don't need a massive matrix switcher for that either. They included an HDMI loop-out port.
Ah, so you can just daisy-chain multiple Avenview units together.
Exactly. You're effectively scaling the canvas infinitely right from the rack.
That's incredibly smart. But that actually brings up another issue. Even with perfect pixel mapping and scaling, you still have to deal with the physical hardware.
You mean the actual plastic bezels between the displays?
Right, the borders. So the processor does things like dual content display and picture-in-picture, which is great. But the bezel correction feature is crucial.
Oh, absolutely. And it's not just stretching the image to fit, which looks terrible.
Right. It's actively calculating the physical width of the bezels and effectively hiding the pixels that would sit behind them.
Yeah, so it maintains the spatial reality. I mean, if a perfect circle moves across the center of the wall, bezel correction ensures it doesn't suddenly warp into an oval.
Which would break the whole illusion.
Exactly. It drops the visual data that overlaps the plastic, making it look like you're looking through a window with mullions rather than just staring at 4 separate TVs.
And honestly, for $2,999, and I actually spotted a sneaky 10% off code hidden in the listing, that is a vital feature.
Oh, totally.
But keeping that geometry intact gets so much harder with fast-moving video, like sports or action movies.
Right, and that's where the commercial-grade processing really kicks in. The specs list, 3D motion adaptive deinterlacing, and a 3.2 and 2.2 film mode.
So it handles the frame rates.
Yep. The film mode correctly maps 24-frame cinematic content to standard 60 Hz displays without that annoying judder. And the adaptive deinterlacing stops fast motion from tearing.
So no matter how fast the action is moving across the screens, the algorithms keep it perfectly smooth across all 4 displays at the same time.
Exactly. The illusion remains totally unbroken.
So just to pull this all together for everyone listening, the Avenview processor relies on raw, uncompressed power, PC-free customization, and this really smart bezel hiding software to build these flawless visual experiences.
Yeah, it basically takes what used to require a whole server rack of IT gear and distills it into just a single, highly efficient box.
It's amazing.
Yeah.
Which, leaves me with one final thought for you to ponder today.
Oh, what's that?
Well, as this high-end scalable processing tech gets more streamlined and way more affordable, how long until customized, irregular architectural video walls completely replace the standard single-screen TV in our very own living rooms?